In this video, we'll learn how to solve equations with numbers outside the absolute value. Because now we're going to have constants outside the absolute value, we need to add steps to the method for solving these absolute value equations. And that is that we need to first isolate the absolute value. Now, what does it mean to have constants outside the absolute value? Well, if you look at the left side of this equation and only at the left side of the equation where the absolute value is, now not only do we have that absolute value, but you also have this number outside of it. Before you start creating the two equations, we need to remove anything that is outside the absolute value. That means that we need to isolate the absolute value. So let's try that. Let's see what we can do to isolate the absolute value. So because we have subtraction, the opposite of subtraction would be to add. So to isolate the absolute value, I'm just going to do those inverse operations. So when I do that, I'm left with the absolute value of 5x plus 2. And that's going to go away. That's going to go to 0 because minus 4 plus 4 is 0. And on the right side now I have a 13. So now that we've isolated the absolute value, we can create our two equations. So let's read and see what they're asking us to do. This one is saying that 5x plus 2 is 13 units away from 0. So the two equations become 5x plus 2 is equal to positive 13 because positive 13 is 13 units away from 0 on the right side, or it can be that 5x plus 2 is equal to negative 13 because negative 13 is 13 units away from 0 but on the left side. We begin then. We've already isolated the absolute value and created our two equations. Now we can find the location of our variable. For the first one is on the left side, and I have addition and multiplication. So the opposite of addition is subtraction. So I subtract 2 from both sides. From left to right, this gives me 5x. Remember, this goes to 0. 2 minus 2 is 0. And on the right side, I have 13 minus 2, and that would give me 11. I still have the multiplication to take care of, so the opposite of multiplication is division, so we divide both sides. So 5 divided by 5 will give me 1. Don't lose the x or the equal sign. And on the right side, I cannot divide 11 by 5 evenly, so I'm just going to leave it as 11 divided by 5, or 11 over 5. That means our solution will be x equals to 11 over 5. Let's go to the second equation. Remember, this is only the solution for the first equation. On the second equation, my variable is still on the left, and I have addition and multiplication. We move addition first by subtracting both sides. From left to right, this gives me 5x. 2 minus 2 will go to 0. Don't lose the equal sign, and on the right side I have negative 13 and negative 2. Same sign, we add and keep the sign, so that gives us minus 15. Don't forget, we still have to get rid of this multiplication, and we do that by dividing both sides of the equation. So 5 divided by 5, again, is 1. Bring down the x. And on the right side, minus 15 divided by 5, well, 15 divided by 5 is 3, and because they have different signs, this will be minus 3. So then the second solution will be x is equal to negative 3. So our two solutions for this absolute value is 11 over 5, and the second will be minus 3. Now notice that every single example we've done so far has had two solutions, but that is not always the case. So we try example 5 here. Now on the left side, the absolute value is not isolated. It has this minus 2 outside of it. That minus 2 is multiplying the absolute value. So that means that I have to get rid of that first before I can create my two equations. So then let's isolate the absolute value. So we divide both sides of the equation by that -2. Now -2 divided by -2, remember that goes to 1. But just like before, you know how we had 1x, we were able to just write x without having to write the 1? Then the same thing will happen here. I'm going to stop writing the 1 and then just bring down what remains. On the right side, 0 divided by -2, well, that's going to be 0. So what exactly does this say? This is the absolute value of x plus 1 is equal to 0. That says that x plus 1 is a distance, let me write it down, a distance of 0 from 0. So what is the only number that is 0 units away from 0? Well, then that's 0 itself. There's no other number that is 0 units away from 0. Then the only equation that this creates is x plus 1 is equal to 0. This time, because your absolute value equals to 0, you only get one equation, because the only number that is 0 units away from 0, it's 0. And now we solve. On the left side is our variable with addition. The opposite of addition is subtraction. So then I have x. Now 1 minus 1, that goes to 0. And on the right side, 0 minus 1 is -1. So then this time around, we don't get two solutions. We only have one solution. Then absolute values don't necessarily have to have two solutions. Sometimes they're going to have one solution. Let's try another example here. Let's continue with example 6. This time, my absolute value is on the right side. And it's not alone. It has this multiplication by 5, and then it's adding a negative number. So this time around, there are two values that I have to remove before I can fully isolate the absolute value. Now you have to be careful here. First, we need to move anything that is being added or subtracted. In this case, since we are adding a -7, when you add a negative number, the operation being applied here is subtraction. So then the opposite of subtraction will be to add. So we add +7 plus 7. From left to right, 13 plus 7 will be 20. On the right side, -7 plus 7, that goes to 0. Don't forget, we still have that multiplication by 5 and then the absolute value of 3x minus 2. So now we need to isolate the absolute value by getting rid of this multiplication. The opposite of multiplication is division, so we divide both sides by 5. So 20 divided by 5, that is 4. On the right side, remember 5 divided by 5 goes to 1, and we're not writing that anymore. So then becomes the absolute value of 3x minus 2. Okay, so we've fully isolated the absolute value because there is nothing before or after the absolute value. So now we are ready to create our two equations. Very carefully, the way that we read this
one reads 3x minus 2
is a distance of 4 from 0. So then the two equations will become 3x minus 2 is equal to +4, and the other will be that 3x minus 2 is equal to -4. So we begin then. My variables on the left, and I have subtraction and multiplication. I add 2 first to both sides because first we move anything that is being added or subtracted. That's going to give me 3x. This goes to 0. It's equal to 4 plus 2, that's 6. Now we need to undo the multiplication by dividing, so I'm going to divide both sides by 3. Remember, 3 divided by 3 goes to 1, so that's 1x or just x. We're not writing the ones anymore. And then 6 divided by 3 will give me 2. So here's my first answer. I go to the second equation and I see that my variable is still on the left, that I have subtraction and multiplication. So the opposite of subtraction will be addition. I add 2 to both sides. From left to right, that gives me 3x is equal to, because this is going to go to 0, and then minus 4 plus 2. Different signs, we subtract and keep the sign of the largest, so that gives me minus 2. We get rid of this multiplication by 3 by dividing both sides by 3. This goes to 1, remember, so we just write x is equal to, well, 2 cannot be divided by 3 evenly. This is a proper fraction, so we're just going to leave it as that's minus 2 over 3. So then the two solutions for this particular absolute value is 2 and minus 2 divided by 3. Let's try one last example. All right, let's try our last example, number 7. We're going to isolate the absolute value. If you notice this time, the absolute value has this addition of 6 that we need to remove to isolate the absolute value. So since 6 is being added, we're going to subtract 6 from both sides. 6 minus 6 goes to 0. Bring down the absolute value of 2x minus 5 is equal to negative 5. And we're going to stop here for a second. Remember in example 1, we had the absolute value of x is equal to 3. So the solution was x was 3 or negative 3. But then we said that the absolute value measures distance, and that distance is always positive. So when we did the example for the absolute value of x equals negative 3, because this one is saying that distance is negative, this one was no solution. Now check our example here. Now we have an absolute value that equals a negative number. So then this one is saying that 2x minus 5 has a negative distance of 5 from 0. Because in this case, distance is given to us as being negative, then this will also have no solution. So let's recap. Okay. The 3 types of solutions. If your absolute value equals a positive number, you're going to have 2 solutions. Okay? If the absolute value equals 0, then you're going to have only 1 solution. But if your absolute value equals a negative number, then you're going to have no solution. Now, this is once you've isolated the absolute value. So the very first thing you do is isolate the absolute value, then see if your absolute value equals a positive number, equals 0, or equals a negative number. That way you know how many solutions you should have at the end when you have completed solving the absolute value equation. Thank you so much for watching, and I'll see you in the next one.